In this video, I'm going to demonstrate how to complete one of the hypothesis of association problems. It's number 2 in my book, but I've got an old edition and I left my new edition at work, so this may or may not be the same as number 2 in your edition, but hopefully this is helpful to you nonetheless. Anyway, in this problem, the hypothesis is that there is a significant association between height and running speed. And they've got a random sample of 8 children, and each one is measured for height and running speed for the 40-yard dash. And of course, this lower time means faster runner. So let's go through the process. Number 1 is to identify our parameter, is the correlation coefficient for running time and height. Okay, number 2 is the hypotheses. The null hypothesis is that there is no relationship between height and running time. And the alternative hypothesis is that there is a relationship between running height and running time. Let's see. Better. Okay, number 3 is the critical value. To get this, we're going to look at table E, I believe it is. I've copied that over here. And notice that at the very top, it even tells you you need to take the number of pairs of scores minus 2 for your degrees of freedom. So we have 8 pairs of scores for this particular problem, 8 children who participated in the study. 8 minus 2 is 6, and the critical value here is 0.707. Nice. Let's see if I can find there. So 0.707 is our critical value. Next is for the actual test statistic. And this is computed from the data. In this case, it's the correlation coefficient of these two sets of numbers. So correl, highlight the first column, comma, highlight the second column. And that gives you the correlation coefficient. So you can see that this is a very large correlation coefficient, very close to 1, or -1 rather, larger than the critical value. And so the conclusion is we're going to reject the null hypothesis, and the conclusion is that there is evidence to suggest that height and running time are related. Oh. There we go.